Hey guys, so good news, this is probably my last video because I'm going to be back at school on Tuesday. So with that being said, we're going to go through some video notes today. You're going to do some practice, and then you'll have a long weekend. So these notes are to be able for you to use the Pythagorean theorem to find the distance between 2 points, mainly on a coordinate grid. So, an example of what a question that you'd be faced with is use the Pythagorean theorem to help you find the exact distance in units between point A and point B on the grid below. So before I actually show you directly, I'm going to show you all the steps that we need to do in order to make this happen. So step number 1, we are going to connect points A and B with a straight line. So we're going to connect points A and B with a straight line. And we're going to use the grid to help you make a right triangle with the line from A to B as the hypotenuse. All right, so looking at my grid, I can see that I have my point A, my point B, and they're wanting to know the exact distance between these two. When I was at school on Monday, we did those squares where I had you lay them on the side of a triangle and have you estimate. It was kind of trickier to see the actual distance between these things. So we're going to actually use the grid lines for our benefit today. So I'm going to make a straight line to create, or 2 straight lines to create this 90-degree angle. And then I'm also going to be connecting the points A and B. So by me drawing those 3 lines, I formed a right triangle. I know that my 2 sides that connect in the right triangle are called legs. So here are my legs. I know that the side that is opposite of my right triangle is called the hypotenuse. Hypotenuse. So if I'm going too fast in this video, make sure that you're pausing it so you're able to write down all of these things too. All right, so step 2. We are going to count the units. We're going to count the units on each leg and label their lengths. Okay, so that seems easy enough. We're just going to see how long this side is and how long this side is based off of the grid. So I have 1, 2, 3, 4, 5, 6. So this is the side of 6. I have 1, 2, 3, 4, 5, 6, 7, 8. And this is the side of 8. So I know my 2 leg lengths are 6 and 8. My step number 3 is use the lengths. So again, we don't know this distance because we can't just go ahead and count all the perfect grids. So we're going to use the lengths that we can count. And we're going to apply the Pythagorean theorem. And we're going to be able to solve for this distance, or the hypotenuse distance. So in this case, since 6 and 8 are my 2 legs, I know that those stand for my A and my B. So I'm going to replace my A and my B with my 6 and my 8. So I have 6 squared plus 8 squared. And it is going to equal C squared, since C is my hypotenuse. From here, I'm going to go ahead and simplify down. So I know that 6 squared is 36, 8 squared is 64. And if you don't know these yet, then you can go ahead and use a calculator and just find it with your exponent key. So I'm going to add up these numbers. So it's 36 plus 64 is 100. and 100 equals c squared. Now, if I put 100 as my answer, I would get it wrong because I don't want a c squared. I just want a plain c. So in order to get away from this exponent, I'm going to have to square root that, which means I'm going to have to square root my 100 as well. Square root of 100, if you don't know that off the top of your head, you can use your calculator. Find the square root button on your calculator. And your answer is going to be 10. So the distance from A to B would be 10 units. Now, I want you to pause the video. I want you to try this practice problem by yourself, and then you can unpause it and play it again, and I will walk you through this problem. So pause your video now. All right, so now that hopefully you've tried this, we're going to go ahead and work this problem out. So the practice problem says to use the Pythagorean theorem to find the approximate distance. So approximate means that we're taking our best guess by proving it. Best distance of the line segment shown on the grid below from 40 to 04. And if necessary, we need to round to the nearest tenth. Nearest tenth is the first decimal place. All right, so we would only have one decimal place in our answer. So going back to my steps, I know that I need to make this into a right triangle. I already have my hypotenuse drawn. So I need to label my legs. So I have this vertical leg is a unit of 4. And this horizontal leg is also a unit of 4. So plugging this into my formula, I would have 4 squared plus 4 squared equals c squared. So I would simplify these down. 4 squared is like taking 4 times 4, so that'll be 16. And then I have another 16, and this is going to equal c squared. Now, when I add my two numbers, I'm going to get 32 equals c squared. I'm going to square root these two numbers because I do not want this little exponent of 2. I need to get rid of that. And in order to get rid of that, I have to square root. So my final answer would be about 5.7 units. All right, so I want you to turn your paper over, and we're going to do some more examples on the back side. All right, so we have this large problem that has kind of a unique triangle on it, and in order to get all of the parts that we need for this, we're going to have to do these steps multiple times. So use the given figure for the problems below. If necessary, round your answers to the nearest tenth. Show your work. So again, the nearest tenth means 1 decimal place. 1 decimal place is all we need. All right, so this has broken it down into 3 different parts. Each part is going to be focused on one side of the triangle. Now, since all of these sides of the triangles are diagonals, meaning that they don't cross the grid perfectly, we're going to have to use our knowledge of Pythagorean theorem. So part A, it says find the distance between point A and B. So I'm going to look for point A and point B, and I'm going to make a right triangle. And I'm going to draw a line straight down and then a line over. So here are my 2 legs because they form the right angle. I can see that I have 1, 2, 3, 4, 5, 6 units here. And this is just a single unit, so I have a 1. So by knowing that my 2 leg numbers are 6 and 1, I'm able to plug that into my formula. So I have 6 squared plus 1 squared equals c squared. And again, c is this diagonal side that I want to look for. That's what I'm trying to find. So when I simplify this down, 6 squared is 36, 1 squared is just 1, and I still have my c squared. I'll combine my 36 plus 1, and that would equal 37. And in order to get rid of this exponent, I'm going to have to square root. So when I square root my 37, it is going to equal 6.1 units after I've just done my 1 decimal place. Next one, I'm going to look for B to C. So I'm going to go from B, I'm going to go over, and then I'm going to go up to the C. So I formed a right angle. And since I formed my right triangle, I know that this is one of my legs. So this is a unit of 3. And this is a unit of 1, 2, 3, 4. So using those two numbers, I'm going to plug them into my formula. So I have 3 squared plus 4 squared equals C squared. When I simplify these down, 3 squared is the same thing as 9 because 3 times 3 is 9. 4 squared is 16. And then I have C squared again because I'm trying to figure out what this C is or what the hypotenuse is. So I'm going to add up my numbers. 9 plus 16 is 25. I'm going to square root the 25. So the square root of 25 means that this side is just going to be 5 units. So far I know that this side is 6.1. I know that this side is 5. So 6.1 and 5. Now I'm going to work on that last side, my A to C. So I'm going to go from C, I'm going to go up and then over. So I went up 2 and then over 4. So those are my 2 side lengths. Notice that once I got done with drawing in my right triangles, it has made a perfect rectangle as well. So that's an easy way to remember how to do this as well. You can just make the rectangle. All right, so looking at my triangle, I have 2 squared plus 4 squared equals C squared. I'm trying to figure out what this black line would be. So I would take 2 squared would be 4. 4 squared is going to be 16. And it's going to equal C squared. I'm going to combine my numbers together. So 4 plus 16 is 20. And then I'm going to square root my 20. When I square root 20, again, you can use it in your calculator. Your answer would be 4.5 units. So this side is going to be 4.5. And then my last question dealing with this shape is, what is the perimeter of the triangle ABC? So perimeter means that we're going to add up all of the sides. Well, I've already done all the work. All of these numbers. So this 6.1 is this side. 5 would be this side. And then I have my 4.5. So I would add up all 3 of my sides that I found. So 6.1 plus 5 plus 4.5. And that would equal 15.6 units. All right, so the last problem. The grid below shows a map of the town. Which gas station is closer to Dan's house and by how much? Round to the nearest tenth of a unit. So we're going to make a right triangle going from the gas station to Dan's house. So start going by going down and over. And then I'm going to show that angle by drawing the diagonal. So this lower part is 1, 2, 3, 4, 5 units. This vertical part is 1, 2, 3, 4, 5 units as well. So since I'm going to be comparing both gas stations, I'm going to label my work so I know what I'm talking about later. So gas station number 1. I know that I have my A and my B. I'm going to go ahead and simplify these. So 5 squared is 25. This 5 squared is also 25. And I'm going to go ahead and add these together. So I have 50 equals C squared. In order to get that C squared, or that distance, this is going to be square rooted. And once I round it to the nearest 10th, meaning that the first decimal place, I'm going to get C equals 7.1. So this unit is going to be 7.1. Now, I'm going to do the same idea for my gas station number 2. I'm going to go down and then over. Notice how this side kind of copycats the gas station, which is fine. I just have to remember that it's its own separate triangle, okay? So this triangle is actually, instead of a 5, it's actually going to be a 6, because I went one more unit down. And then this is a side of 3. So for gas station number 2, I have a side of 3 and a side of 6, and I want to figure out what this hypotenuse is, so I need to leave that as a C. I'm going to simplify these. So 3 squared is 9, 6 squared is 36, that equals C squared. I'm going to add these two numbers together to make this 45. And in order to get this C squared away, I need to square root this. When I square root it, I'm going to get 6.7. So this distance is 6.7. So, which gas station is closer? So would you rather walk 6.7 or 7.1? I know it's not a big difference, but we see that gas station number 2 is closer. And then by how much? So I would subtract the two distances, and that would be 0.4. So if this was talking about miles, that means that it would be 4, or a little less than half a mile difference. All right, you have a practice page to be working on. Please use these notes, rewatch the video, pause the video if you need to, and then submit your answers in the Google form from the practice page.